Alright you guys, this video goes over 13-5, the cosine function. The cosine function, y equals cosine of theta, matches the x values of the unit circle. Okay? So cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, and cosine of 3 pi over 2 is 0. And then cosine of 2 pi is 1 again, and round it goes. So the graph looks something like this. As you can see, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is 1. Now, you guys have been learning about sine for the past couple days, and you've probably noticed a few similarities between sine and cosine. I'm going to switch screens really quick. Okay, this is the graph of sine and cosine graphed together. The red line is the graph of sine, and the blue line is the graph of cosine. As you can see, they're pretty much the same thing. They're just phase shifts of each other. By phase shifts, I mean if I was to shift cosine over pi over 2 units, it would completely overlap sine. Okay? And the same thing with sine. If I was to move sine pi over 2 the other way, they would overlap. So you're going to notice that a lot of the things you learned about sine are also going to be true for cosine. For example, example 1, use the graph shown above to find the domain, period, range, and amplitude of the cosine function. The domain is going to be all real numbers, because if I was to extend this graph in both directions, the graph is going to cover all x values from negative infinity to infinity. As for the period, the function goes from its maximum value of 1, it goes down and then back up again to 1 over the course from 0 to 2 pi. So the period is going to be 2 pi. The range is going to be from negative 1 to 1, because if you look at the graph, the lowest value, the minimum value, is negative 1, and the maximum value, the highest value, is going to be 1. There we go. Now the amplitude can be found using this equation, 1/2 times the maximum value minus the minimum value. Now I already mentioned that the maximum value is 1, and the minimum value is negative 1. So let me plug in those values. I have 1/2 times 1 minus negative 1. This minus negative is going to become a positive. 1 plus 1 is 2, and half of 2 is 1. And I boxed all of the answers so that you could see them a little better. Alright, examine the cycle of the cosine function in the interval from 0 to 2 pi. Where in the cycle does the maximum value occur? Now if you look over here, the maximum value occurs at 0 and then again at 2 pi. Those are the two places where the function hits its peak. Where in the cycle does the minimum value occur? If you look at the graph, the minimum value occurs right here at pi. There we go. Alright, so suppose y equals a times cosine b times theta, with a not equal to 0, b greater than 0, and theta is in radians. You can probably figure out what goes in the blanks here. It's very similar to sine. The absolute value of a is the amplitude. B is the number of cycles from 0 to 2 pi, and 2 pi over b is the period of the function. So let's take a look at what that would look like in an actual example. Example number 2. Sketch the graph of y equals 1.5 cosine 2 theta in the interval from 0 to 2 pi. So let's find the amplitude, the cycles, and the period. The amplitude is the absolute value of a, which is the absolute value of 1.5, which is just 1.5. And I got that because 1.5 is right here. The number of cycles, b, is 2. I got that from right here. The period is 2 pi over b. b is 2, so I've got 2 pi divided by 2. The 2's cancel out, and I'm left with pi. So the period is pi. Alright, now, to graph a cosine function, you're going to want to locate 5 points equally spaced through one cycle. Okay? So, we know that the period is pi. So I'm going to be looking at the space in between 0 and pi. So at 0 and at pi, because I know the amplitude is 1.5, it's going to hit 1.5 at both 0 and pi. In the middle of that, it's going to hit negative 1.5. Like that, like that. And halfway in between this point and that point, it's going to hit 0. Here. And here. There you go. There's one cycle. And then in the second half of the graph, it just repeats itself. Just like that. Alright, I'm going to switch screens here. This is another worksheet that covers different transformations that you can do with cosine. Now, today we're just going to be dealing with a and n. On this worksheet, it calls it a and n. You guys learned it as a and b, so go ahead and ignore these other two things here. In our case, the amplitude was 1.5. So if I move this over to 1.5, there we go, you can see how the graph changed. Now n was 2, so I'm going to move this over to 2. So this is what the graph looks like in comparison to what the original cosine graph looks like. Okay? Just to give you guys an idea. Alright, let's go back over here. Now, sketch the graph of y equals negative 1/2 cosine pi of theta. Alright, now, when a is negative, the graph changes a little bit. Take a look at what happens when I make a negative. So, before it was like this, the bigger a is, the taller the graph gets. The smaller a gets, the flatter it gets. And then, once a becomes negative, the graph flips upside down. You see that? So, let's take a look at what that looks like. I'm going to scroll back up to our original graph. The graph of y equals negative cosine of theta is the same graph except that it's flipped upside down. So I've graphed it on the same coordinate plane so that you guys can see it. My graph of cosine of theta is purple and my graph of negative cosine of theta is blue. Okay? So, well, in this case, because we see that we have a negative 1/2 here, we already know that our graph is going to be upside down. So let's find our amplitude, cycles, and period. The absolute value of a is going to be the absolute value of negative 1/2, which is just 1/2. The number of cycles is b, which is pi. And the period can be found by with 2 pi over b. In this case, b is pi. The pi's cancel out, so my period is 2. So I'm going to graph this the same way. I went ahead and labeled these by fourths. You don't have to label it the same way I did. It just makes it a little bit easier, I think, to have it this way. The amplitude is 1/2, and the period is 2. And we know that because it was a negative 1/2 to begin with, the graph is going to be upside down. So it's going to start at negative 1/2, and it's going to end at negative 1/2. Halfway in between, it's going to be positive 1/2. And then halfway in between that, it's going to hit the x-axis. So the graph is going to look something like this. I made a mistake just now. I meant to put that dot right here. There we go. So the graph is going to look something like this. There you go. Okay. Alright, example 3. The figures below show the vertical motion of a particle in water as a wave moves by. Suppose 10-inch waves occur every 4 seconds. Write an equation that models the height of the particle as it moves from crest to crest. When you're trying to come up with an equation to model a certain situation, you're going to want to first find your amplitude and your period. Now, if you guys remember, I told you at the very beginning that the amplitude could be found using this equation. 1/2 times the maximum minus the minimum. Now, from the information in the problem and from this diagram here, if there are 10-inch waves, I know that the maximum height is going to be 10 and the minimum height is going to be 0. So I plug those values in. 10 minus 0 is 10 and half of 10 is 5. So my amplitude is 5. Now, the period, in the problem it says that the waves are coming every 4 seconds. So we know that the period is going to be 4. So 2 pi over b equals 4. But in order to find my equation, I need to figure out what b is. So I'm going to work backwards and try to solve for b using this equation. First thing I'm going to do is multiply both sides by b. The b's cancel out over here, and I'm left with 2 pi equals 4b. I'm going to divide both sides by 4. The 4's cancel out. 2 over 4 is the same as 1 over 2. So b equals pi over 2. So if this is my amplitude and this is my b, here's my equation. Y equals 5 cosine pi over 2 theta. Alright, let's try these over here. Okay, so here I have my amplitude is 4 and my period is 6 pi. So this is what we have. Now the absolute value of a, when you remove the absolute value, you could get 4 or negative 4, but here it says to choose a greater than 0, so we're just going to deal with positive 4. Okay, so I have my amplitude, I have my a, now I need to find my b. So I'm going to solve this equation here. I multiplied both sides by b, the b's cancel out, so now I have 2 pi equals 6 pi b. I divide both sides by 6 pi. 6 pi's cancel out over here. 2 pi over 6 pi reduces to 1 over 3. So my a is 4 and my b is 1 over 3, which means that my equation is y equals 4 cosine 1 over 3 theta. Alright, so now I have an amplitude of, where's my cursor? There it is. An amplitude of 2.5 and a period of 8. So this is what I have. Once again, I'm going to choose positive 2.5 because it tells me to choose a is greater than 0. And I'm going to solve for b here. I multiply both sides by b. The b's cancel out, and I'm left with 2 pi equals 8b. I divide both sides by 8. 2 over 8 reduces to 1 over 4, so I've got pi over 4 equals b. So my amplitude is 2.5, and my a is 2.5, and my b is pi over 4, so my equation is y equals 2.5 cosine pi over 4 times theta. Alright, example number 4. Suppose you want to find the time t in seconds when the particle from example 3 is exactly 3 inches above the average height represented by y equals 0. Solve 5 times cosine pi over 2t in the interval from 0 to 8. We're going to need our graphing calculators for this problem. I don't know how familiar you guys are with your graphing calculators, but I'm hoping that you guys know how to use the window. For this particular problem, you're going to want to change the window so that your x-min is 0, your x-max is 8, your x-scale is 1, your y-min is negative 8, your y-max is 8, and your y-scale is 1. And you don't have to do it this way. This just turns out, it just works out that the graph is easier to read with these dimensions. When you're working on your homework at home, you can just play with these dimensions until you get a good view of the graph. But it just turns out that this works for this graph. Alright, then we're going to go to our y equals. I'm going to graph y equals 3 and y equals 5 cosine pi over 2t on the same screen. So, for y1, I'm going to put 3. For y2, I'm going to put 5 cosine, pi, there it is. And t is the same thing as x. And now I'm going to graph it. There we go. Okay, so as you can see, the solutions here are the places where these two lines intersect. Basically where these two sides equal each other. So we're going to get 1, 2, 3, 4 solutions. I'm going to go ahead and use my intersect button. So I'm going to hit second calc. Intersect is number 5. First curve, enter. Second curve, enter. Guess. There's one of them. So 4.59. I rounded to 4.6. So let's go ahead and find another one. Okay. So, second calc, 5. This time we move the cursor over this way. Second calc, 5. First curve, enter. Second curve, I'm going to move the cursor over this way. Try to get this one. Enter. Guess. There we go. 3.4. Alright, I'm going to try to find another one here. Second calc, intersect, first curve, enter, second curve. Let's move over to this one over here. There we go. Enter. Guess. Looks like 0.6. There we go. Okay, clear. And let's try to find the last one. Second, calc, intersect. First curve, enter, second curve. Okay. Enter. Guess. 7.4. Okay. I rearranged the numbers so that they're in order from least to greatest. That's really how you should write it. Alright, let's try these ones. So, find all solutions in the interval from 0 to 2 pi. 3 cosine 2t equals negative 2. Let's pull up the calculator. Okay, I changed the window for this one also. Because I'm looking at the interval from 0 to 2 pi, I have my x min 0, my x max 2 pi, and the scale is still 1. Because I can see the amplitude is going to be 3, I decided to go from negative 4 to 4 just to be a little bit higher and lower than the actual amplitude of the thing, and my scale is still 1. So, here I'm going to type in 3 cosine 2t, 2x rather, and negative 2. Graph it. There we go. Okay, so same thing. You just use second calc, intersect, first curve, second curve, enter, guess. There's number 1, so 4.3. There we go. The other 3 solutions are just a repeat of the way you found the first solution. So let's try the next graph. Alright, oops. This should be 1 and this should be 2 pi. Alright, so I kept most everything the same except now I made my y min, y max negative 3 to 3 because I can see the amplitude is 2. Okay, so I'm going to go to y equals, I'm going to put negative 2 cosine of x and 1.2. Graph it. There we go. Okay, so then second calc intersect, first curve enter, second curve enter, guess. The first intersection point is 4.1. Okay, and I went ahead and just wrote down the other answer. You find the other answer the exact same way. You just use the cursor to come over here. Alright, part C. In the interval from 0 to 2 pi, when is this less than 1.2? Negative 2 cosine theta is less than 1.2 from here to here, and then also from here to here. So between 0 and 2.2, and then from 4.1 to 2 pi. The graph is greater than 2, be in between 2.2 and 4.1. And there we go. And I will leave the challenge question for you guys to ponder. And that concludes 13-5. Thanks, you guys.